Hello and welcome to Mechanical Why. Humans have been exploring space for about 70 years. We have reached some major milestones during this time, all of which have culminated in the International Space Station, a magnificent feat of not only engineering but also multinational cooperation. But we are at a crossroads. What is the next step in human spaceflight? Right now there are two most likely paths that we can take. The first takes us back to the moon, a feat which we have already accomplished though it's been some time. The second takes us to Mars, the nearest planet on which we can safely land. So where do we go? To which of these two places do we commit our resources? Many say that Mars is the next goal. We have already been to the moon and it seems much more plain and boring by comparison to Mars. I agree that Mars is the next major goal in human spaceflight, but I believe our immediate resources ought to be committed to returning to the moon. But first, let's be clear that sending a manned capsule to another place is always the ultimate goal. Life is about the human experience, so robotic exploration just will not suffice. Second, let's assert that scientific research is enough of a reason to go to either of these places. Many try to constrain space exploration to missions that yield a financial profit or material gain. But going to these places simply to increase our understanding of the universe is indeed enough. Though granted, it may be a little difficult trying to find funding if people don't think that they can make money on the venture. So why go to the moon first? Mars does potentially have a lot more to offer than the moon, but Mars is simply too far away to be our next step. A trip to Mars would take as much as 6 months each way. Due to Mars's orbit being unique from Earth's, a mission would likely take about 3 years round trip. Even light-speed communications take on the order of 20 minutes to several hours to reach Mars, depending on where it is in its orbit. It would take a tremendous feat of engineering to get us to Mars. Though 70 years seems like enough time to give us the confidence that we need, we must remember that we are still novices when it comes to space exploration. Only 12 people in the history of humanity have ever walked on another heavenly body. And not to get too morbid about the subject, half of these people are already dead. Reaching the moon still represents a great technical challenge, and the science that can be done in an environment like the moon's is still substantial. But the moon does come with advantages when compared to Mars. It's closer, meaning that it only takes on the order of days to reach it. It takes seconds to send a message via light-speed communication to the moon. And because it's always in orbit around the Earth, aborting a mission due to emergency is much easier. We must gain expertise traveling to and landing on other heavenly bodies, starting with the moon before we try to tackle Mars. The half-dozen missions we flew over 50 years ago just aren't enough. Let's look at the Apollo program for guidance. Apollo 11 successfully landed people on the moon. Why was it Apollo 11 and not Apollo 1? Well, we ran into some problems and had to practice first. Apollo 1 exposed a fatal flaw in the capsule design that ended up in the deaths of 3 astronauts. What would have been Apollo 2 and 3 were cancelled due to practical limitations. Apollo 4 was an unmanned test flight of the Saturn V rocket. Apollo 5 was an unmanned test flight of the lunar lander. And Apollo 6 was the second test flight of the Saturn V rocket. And here we exposed another potentially fatal flaw in the rocket design. What was this flaw? When the engines were tested here on Earth, cryogenic propellants flowed through hoses to the engines. They cooled the hoses and caused frost to accumulate, stiffening the hose. At altitude, there was no humidity in the air to generate frost, so the hoses remained flexible during the launch, and they simply rattled apart and caused a failure. This could have been fatal if this was a manned mission. Apollo 7 was the first successful manned Apollo mission, and it merely reached Earth orbit. Apollo 8 actually went all the way to the moon, but only orbited without attempting to land. Apollo 9 stayed in Earth orbit and performed manned test flights on the lunar lander. And Apollo 10 went all the way to the moon, separated a manned lunar lander, and came within 10 miles or 16 kilometers of the lunar surface, but it did not land. It wasn't until we finally sent Apollo 11 to actually land on the moon. But even with these astronauts, they only stayed on the moon for a matter of a couple of hours because of their safety concerns. Our longest residence time on the lunar surface has only been about 3 days for a single mission, far from the 2 years that are expected on Mars. We repeated Apollo 11's feat of landing people on the moon with Apollo 12, but on our third attempt, when we experienced a catastrophic failure during Apollo 13 that forced an abort of the mission and almost cost the lives of 3 astronauts. Only after all of this did Apollo 14 through 17 finally go off without major issue. As you can tell, there was a tremendous amount of preparation that went into reaching the moon, and not everyone survived the experience. As an engineer and someone who has studied spaceflight for many years, I would expect nothing short of this level of preparation for a Mars mission. And part of that preparation, I believe, necessitates manned practice landings on the moon and extended residence times on the lunar surface. Well, thank you for watching. I hope you found this interesting. If you did, please like and share this video, and please subscribe to stay up to date on new content. Also, please visit us at our website, www.mechanical-y.com.